Do you use this gradient formula but yet get the wrong answer? If so, watch this video. If you have watched all of the previous videos in the calculus playlist leading up to this one, then it would be quite easy for you to get what I'm about to go through in this video. If you are new here, I am Astrid Nelvita, the Maths Mentor, here to help you pass your next maths exam. And go watch the previous videos first. I've put a link in the description below and also in the card in the top right corner. Wonderful. Let's take a look at this formula. First, you're told that gradient is rise over run. Now you're told that gradient is y2 minus y1 all over x2 minus x1. What's the deal with that? In actual fact, they are the same thing. In fact, we have been doing this ever since the beginning of this playlist. If you have been watching my videos up to this point, this will come very naturally to you, because as you know, to get the rise, we take the difference between the y values. This is the y value of the point on the right, this is the y value of the point on the left, and this is the run, which is the difference of the x values. This is the x value of the point on the right, and this is the x value of the point on the left. Now, in saying that, it doesn't really matter if the point's on the right or on the left. It just has to match up. So this x value is correspondent with that y value, and this x value is correspondent with that y value in the point. Here we have our 2 points. This is point number 1, this is point number 2. This point will be labeled as x1, y1. So this is the x value of this point, that's the y value of this point. And this point will be labeled as x2, y2. This is the x value, and that's the y value. Then we do our substitution, the y2 minus y1, and x2 minus x1. That will give us the rise, and that will give us the run. You already know all of this. The point that I want to make in this video is that it doesn't matter which point is the first point, which point is the second point. So this point could be x2, y2, and that point could be x1, y1. And it wouldn't matter, it should give us the same gradient. So let's take a note that this is 0.57, and now I'm going to change the numbers so that it reflects the new x1, y1, x2, y2. I have now substituted the new x1, y1 and x2, y2 into the gradient formula, and you can see that it's now, instead of positive 8 divided by positive 14, it is negative 8 divided by negative 14. It doesn't matter. At the end of the day, you're going to get the gradient of 0.57. I hope that it's clear to you from this video that so long as you stick to the correct corresponding x and y values, and that you substitute them in correctly into the formula, it will give you the correct gradient. But nevertheless, the smartest thing that you can do is to use your common sense. Does a gradient of positive 0.57 match the steepness of this line? And I say it does because walking from the left point to the right point, you're walking uphill. That will give you a positive gradient, and it's not too steep, so a gradient of 0.57 do make sense. Let me show you another example. Here is another line between 2 points. I've labeled this point as x1, y1 and this point as x2, y2. We all know to get the rise, we need to take the y value of this point minus the y value of that point. And to get the run, we need to take the x value of this point minus the x value of that point. And that describes the y2 minus y1 all over x2 minus x1. You get your rise, you get your run, and then you get your gradient. If you get confused as to which number to substitute into the formula, I would strongly advise you to label your points just like how I have done here. Label one as x1, y1, the other one as x2, y2, and then do your substitution. Subscribe to this channel to watch the next video, which will be on limits. Do you have a concept in maths that you are struggling with? Comment below and let me know. If you want me to be your personal maths mentor, contact me on my website and let's discuss how I can help you.